The equation x to the power of 1 over 3 minus 3x to the power of negative 1 over 3 equals to 2 is an indicial equation. But the method through which the solution is obtained is actually a quadratic. We're going to see how this indicial equation can be transformed into quadratic equation by setting another variable to represent x raised to the power of positive 1 over 3. And finally, we're going to find x. Now, solution. The equation is x raised to the power of 1 over 3 minus 3 times x to the power of negative 1 over 3 equals to 2. This equation can be written as x to the power of 1 over 3 minus 3 times 1 all over x to the power of positive 1 over 3 equals to 2. Here I have negative 3 times x to the power of negative 1 all over 3x. You can remember one of the laws of indices, that is negative power law, that says when you have a variable, any number you raise to the power of negative power, let's say a to the power of negative 5, then the result is the reciprocal of a to the power of positive 5. So with this, we can generalize. We can write this 3x to the power of negative 1 all over 3 as 3 times 1 all over x to the power of positive 1 all over 3. And this equation also, can be written as x to the power of 1 all over 3 minus 3 to the power divided by x to the power of 1 all over 3 equals to 2. So when you look at this stage of solution, here you have x to the power of positive 1 over 3, and here you also have x to the power of positive 1 all over 3. Unlike the first line where you have the first term x raised to the power of 1 over 3, while the second term is x to the power of negative 1 over 3, which cannot give us the opportunity to make any supposition. So at this stage, since we have positive power, we have positive power also here, we can make a supposition. Like I said, here we set a to be equals to x raised to the power of 1 all over 3. So we make a substitution here. Wherever you see x, we substitute it by writing a. So here we go. Here, instead of writing x, I'm going to substitute it by writing a. So here I will have a minus 3 over a equals to 2. So to eliminate this fraction, I am going to multiply throughout by a. I'm going to multiply this by a. I'm going to multiply this by a. I'm going to multiply the other side by a. So here I will have a times a minus a times 3 all over a equals to a times 2. So the next stage is we balance the equation. So a times a is now a, or write the equation a squared minus this a will take care of this, leaving us with 3. So you have 3 equals to a times 2, or 2 times a, we have 2a. So rewriting the equation, it is clear that this equation is quadratic. We have a squared. So transferring this 2a to the other side, we have minus 2a minus 3, which is equals to 0, which is purely quadratic. So we are not done yet. What we do here, we factorize this quadratic. We factorize it. So by factorization method, factorize the equation, we now have a to the power of 2 minus 3a minus r plus a minus 3 equals to 0. So we group it. Now opening the equation, we now have a out, a in, minus 3 plus, we factor this out, we have 1, a in, minus 3 equals to 0. Is it? So we now have two linear factors. The first one is a minus 3, which is either this one or this one. And the second one is a plus 1, which is a plus 1 equals to 0. So it is clear that a is equals to 3 or a is equals to negative 1. But we remember that a is equals to x to the power of 1 all over 3. That means when a is equals to 3, that's the first option, this implies that x to the power of 1 all over 3 is now equals to 3. Okay, so what does that mean? By taking the cube root of both sides, we now have x to be equals to 3 to the power of 3, which is equals to 27. So also, when a is equals to the second option, which is negative 1, this implies that x to the power of 1 all over 3 is equals to negative 1. So by taking the cube root also of the both sides of the equation, so x is now equals to negative 1 raised to the power of 3. And negative 1 to the power of 3 is equals to negative 1. And therefore, the value of x is equals to 27 or negative 1. So we can use these values and check our initial equation. That's the equation given, and the equation given was x to the power of positive 1 all over 3 minus 3 x to the power of negative 1 over 3 equals to 2. So when x is equals to 27 or negative 1, we're going to substitute these values in order to ascertain as whether the equation is true, that is, the end result should be 2. So going by 27, if x is 27, so we now have 27 to the power of 1 all over 3 minus 3 all over 27 to the power of 1 all over 3. This result should be cube root of, that is for this, cube root of 27 minus 3 divided by the cube root of 27. Okay, and this is equals to the cube root of 27 is equals to 3. Okay, so minus 3, the cube root of 27 is equals to 3. Therefore here we have 3 minus 1, which is equals to 2, which satisfies the equation. So also, when x is negative 1, also we are going to test when x is negative 1. When x is negative 1, we now have negative 1 all over raised to the power of 1 all over 3 minus 3 divided by negative 1 to the power of 1 all over 3. This gives us -1 minus -3. Okay, so this gives us -1 minus minus is plus. Okay, so -3 plus 3 will definitely give you 2, which also satisfies the equation. So therefore we can conclude that the solution to this equation, the value of x is 27 or -1.